I love that we've got the Facebook panel. Like, you guys, I mean, can you imagine if we didn't have Facebook on stage? This would be terrible. Come back. All right, so today we have Jay Parikh, who is in charge of all of Facebook's infrastructure operations, guy who keeps everything up and running, right?
Yes.
So if the site goes down, you're going to watch. He's like a flash. And this is Najim, who is just Najim in networking circles, who is in charge of their networking operations. Yes.
Right.
All right. So this is exciting because for years I have begged Facebook always, like, what's your networking strategy? You've got open compute. You've got this awesome cold storage stuff. They would always put me off. But today they are ready to talk to me about what they're doing. And they are introducing a new networking fabric for inside Facebook. That's what you're working on?
Yeah, so I think before we jump into that, I just want to maybe set the stage for why we're having to do so much innovation on the networking side. We've been doing a lot of work on the hardware side via open compute, storage, compute, et cetera. That, it's all kind of been pushed because the need of our application, or the needs of our application, are such that everything is virtually real time and interconnected. So our traffic kind of going across from machine to machine far exceeds the traffic that's going out from machine to user. I think our ratio roughly is around 1,000 to 1, so there's 1,000 bytes more sent out between sort of our data center, across our data center, than there is going from machines out to users. So there's a huge amplification of traffic that's just, generated and necessary for the real-time nature of our application. This is, to generate pages. It's also doing a lot of the analytics and ranking and all the stuff that's happening in the back end. So for us, it's been in order to kind of eliminate the bottleneck, or to kind of free up the application builders, the services inside the data center, we want to make sure that we can kind of eliminate more and more of the bottlenecks and the oversubscription and sort of this hierarchy that we've been building in the past inside of our data center, to kind of make it just everything more real time, and to sort of give us flexibility in our infrastructure.
And as an end user, because I have to bring it always back to the end user, will they notice anything like this, or is this mostly a cost or a business kind of agility or savings kind of thing?
I think so there's two things, which is one is it's a cost, it's a flexibility part of it, so that we can continue to move fast, we can build more services, and it's sort of a flat topology across the data center. It'll free up and make things like capacity planning and new product launches easier and better for us. So the user should notice the products that we build will be better, they should be faster. For us, it's mainly a flexibility and sort of an operations manageability play.
And we were talking about this earlier, and I think this is a really important point, because the whole point of structure is to talk about how things are changing inside the data center. And one of the things that you mentioned is the vendor community had dictated your network design for so long, and that kind of led it to look a certain way. And now you're kind of trying to, I don't know if undo that is the right word, but you're trying to kind of modify that. So what did it look like, and what are you kind of going for here?
All right, I'll take that one. I mean, if you want to just even go back to when sort of networking technologies were built, they were primarily designed around ISP requirements and ISP networks. And if you look at protocol development, and things like BGP were developed primarily for interconnection of ISP networks. Technology wasn't developed really as much for content or application services. So there are certain things that are fundamental gaps in how what requirements we have from an app perspective versus an ISP. To be specific, there's really no way to communicate between an app and the network today. So the app really just puts the packet on the NIC and then just hopes that it gets to the other end. There's really no communication between them. So there's that level of technology development where how we can come up with structures that technology that allows the application to have a better feel of what the network is doing, where the network has capacity, where there are issues, how do you wrap around and things of that nature, how do you find better, more cheaper things of that nature, paths across the network. Then the other piece is, if you look at the technology developed in those days, it was primarily around platforms And the platforms are very vertically integrated, so you have the chipset, the hardware, the operating system, protocol stack, everything developed by one vendor, and you have to buy the whole thing as a package. It doesn't matter if all things met your needs or not. You had to buy the whole package, and you had to essentially make it work in that environment. Then you look at the hierarchical nature of the network architectures. If you look at the traditional three-layer architectures where traffic was primarily north-south, and network architectures evolved and platforms evolved in that direction of catering to that, it's not that anymore.
Right, instead of traffic going up from a server out to a user, things are talking across the data center to each other, and that's
Right.
just all kinds of trouble.
All kinds of trouble. The apps are humongous. They're all over the place. They move around without actually network knowing what's going on. So in that environment, the hierarchy is actually a bottleneck because we see flash floods, we see choke points, all sorts of interesting scenarios. So going from a more of a cluster by cluster hierarchy where clusters are connected by aggregation layers and things of that nature, that just doesn't scale for us anymore. So building more of a fabric, which is flat, if you will, and if you take an entire data center, if you can build a fabric that every cabinet, every rack is at the same level, connectivity between any two racks is uniform, then you have a better chance of actually managing the applications, and then the construct becomes more logical than the physical hierarchy-based systems that we have today.
And when you talk about a fabric, it kind of sounds a lot like kind of some of the software-defined networking stuff that people have been talking about for the last couple of years. Is that kind of, are you talking about an entirely software-defined network for all of Facebook? Or am I confusing things?
No, if you think about how you solve the problem, today, networks are a distributed system, if you will, and how they manage this fabric is through protocols. But again, the protocols were developed more for an ISP type environment, not necessarily for an application. Doesn't provide the same level of controls that are required for an application. So how we build those controls is interesting. And the way to do that is through SDN-based technologies, right? So what we want to do is we want to be able to build a fabric or a forwarding plane that can pass bits. It's massive in scale, but it's fairly static. But we can build a software layer on top that allows us to develop new functionality on that fabric much more rapidly. So not having the control of the network also embedded into the platforms itself. So if we can take the control out and be able to iterate over it, then we can move much faster. If you look at all the application development in our environment, the innovation in applications is much, much faster than that happens at the network layer, right? And there's a huge speed mismatch in the app versus the network. So how do we make the network innovation happen much faster? That's what SDN brings. So we can't really build a fabric without actually solving that problem.
And our applications are really, there's a huge variety in them. We have, some systems that have really, really high packet rates and just overall bandwidth is not that interesting. We have other applications that have huge bandwidth needs and consumption because of replication or something like that. One of our services today handles like 2.5 billion hops per second, and it's, a lot of packets being sent over the wire, and latency matters, and this is goes into page generation, so it's a lot of ops that we have to handle. And the network is a choke point. It can be something that is just not, is disconnected from the application needs. The other thing that I'd say also is really important here in the fabric is just an ease of manageability of the fabric, right? Today you have these black boxes that all have different interfaces in terms of how you configure them, how you monitor them, how you repair, remediate them, how you set up, the different protocols, how they fail over, etc. And this is really, really clunky, and it just slows us down in terms of being able to adapt the network to the needs of the software. So having, with this, effort that we've launched within Open Compute around the network switch, the top of rack switch, we really want to have this, this sort of OS agnostic box that allows for us to do the things that Naja mentioned, but also just the configuration, the manageability, repair, remediation, etc.
Right.
All in software, right? So.
All in software, except for the box. Because there always is a box. And yes, you brought it up before I got to. You guys in May announced that you were working on a switch. And if I look at kind of your idealized network, then what we've got is the Open Compute switch. We've got some sort of Linux-based OS that you guys are working on, I think. And then on top of that is your controller that you have built. And then on top of that would be the fabric. Or the controller is kind of like the fabric. I'm trying to create stacks because that's how I make sense of the world.
Yeah. So actually, your might be slightly different.
But not wrong, just different.
Just different. The switch itself is a component of the fabric.
Okay.
So, and there will be different sizes of switches. The first one we're starting, it's pretty basic, simple top of rack type environment. But then we'll have the fabric switch and the spine switches, which will form the fabric itself. And they're essentially cogs in that fabric, devices that we're building. The operating system will allow us to have better programmability and configuration management and things of that nature, that we can use a lot of the knowledge base and expertise we have from the Linux world, from the software side of the world. I mean, we manage hundreds of thousands of machines, right?
Hundreds of thousands of machines?
A lot of machines.
Did I say number? A lot of machines. Which are running our labs. And we have a system that manages tools that manage, configure those devices. But for the network, we have a separate set. And it tends to be network engineers, so we have to go find that can actually do that. Why can't we have the same system manage the network itself as well?
And we're going to talk about some of that, I think, tomorrow.
Yes.
So now let's take it outside the data center, because you guys are also doing some kind of interesting things with undersea cables and doing, I love undersea cables. I don't know, if you read the blog, you would know this, but I love them. So what are you kind of doing, I guess, around there factually? Like, factually, tell me what you're doing with buying dark fiber in Europe, what you might be doing here, what you're doing there, and why this is so important. Because
yeah, I think it's, you know, in some ways it's a similar story. 82% of Facebook users of the 1.1 billion monthly actives that we have are actually outside the US. So for us being able to, you know, reach them reliably, reach them quickly, that's sort of everything that we're trying to do. And we've announced two things, which is one is participation in the Asian Pacific Gateway undersea cable in Asia, and then also the fiber loop that we've been building and operating for powering our Luleå, Sweden data center, but connecting it throughout Europe. And really what this does for us is just gives us that flexibility to move faster. So if we do need to launch a new application, we do need to reach our users in, you know, sort of different developing, growing countries, regions, then the investment in fiber, whether it be cables or, you know, other forms, then like that's what we're trying to do. So some of this is a cost thing, CapEx versus OpEx, but then the other thing is just the flexibility in being able to turn up, you know, capacity much faster as our needs, this sort of machine-to-machine traffic increases.
And to quantify that much faster, we're talking seconds and minutes rather than weeks that it takes today. So we want to be able to point and click or through a signaling mechanism bring up capacity in a matter of seconds or minutes.
And it sounds like, listening to you, because you're inside the data center, you were kind of constrained by the boxes that vendors had given you and protocols and things designed for ISPs, and then going around, you know, buying up your own fiber. It sounds like, if I look at the world, I feel like we're moving from this maybe ISP kind of dominated world to like a world dominated by content providers, and I feel like there's a lot of tension there happening between the two sides. Will that side ever come around? Does it need to accelerate kind of in terms of, I mean, you guys are huge, but what about all the other people who are trying to build companies that are going to work over these networks? Do they have to build their own? Do you see that shifting?
When you say two sides, you're talking ISPs or vendors?
Yeah, okay, you're right. There are three sides.
Three sides.
Well, some of the vendors are really in tune with the ISPs is kind of my thinking there. But we'll say ISPs in kind of maybe just the old way of doing the telecom kind of versus the IP network. Maybe that's a good way to think about it. I don't know.
Yeah, so I think ISPs definitely need to solve the end user connectivity, the access problem, right? Every user in the world needs connectivity, and that problem needs to solve, and that's not what we're really trying to solve from that point of view. So there's definitely that access that those guys need to focus on. The thing that, I talked about this at ITW last time, was that the tension is the over-the-top and under-the-top type conversation of the content being considered over-the-top of ISP networks. ISPs traditionally have two models, retail and wholesale, and we don't fit in either one of them. We're not a wholesale, we're not buying wholesale and reselling stuff, right? So what really needs to happen is more partnerships in trying to figure out what's the best way to serve this particular segment, and that's where things have been slower, that newer models haven't developed. I think where the ISPs and the industry has opportunities is where building cloud-type infrastructures. I mean, if you think about Facebook, we're building our own private cloud and that for our own use, not to sell. But there are enough companies that are building public clouds as well. And if you look at a lot of the startups today, they are just going to those clouds and starting their apps. That's how their startups are doing it. So there's a lot of opportunity for the industry to provide really huge, massive, scalable, manageable infrastructure for all the startups that are coming out. At some point, yes, you get to a scale that building your own is the only way to do it, but there's lots of opportunity there.
Yeah, I think you get to that point when you need to have better control around cost, or you need the flexibility in terms of the time to market of being able to turn things out that you can't get out there from some set of vendors.